I'm Kira Curtin, Senior Editor at GenomeWeb and 360DX, and I'll be your moderator today. The title of today's webinar is Best Practices for Maintaining Quality in Molecular Diagnostic Testing and is sponsored by Zeptometrics. Our speakers today are Jack Zakowski, a principal at IVD Consulting, and Jessica Van Allen, a QC manager at Zeptometrics. You may type in a question at any time during the webinar. You can do this through the Q&A panel, which appears on the right side of the webinar presentation. If you look to the bottom tray of your window, there are a series of widgets to enhance your webinar experience. And with that, I'll turn it over to Jack. Jack?
Okay, thank you, Kira. Hello and welcome to everybody on the webinar today. Thank you for attending. We hope you'll find it of use and of interest. Always need to start off with a little bit of conflict of interest and financial disclosures. I ain't got much. I do consult at Zeptometrics and to Bio-Rad and to Beckman. I've served on the board as president or as chair of CLSI and of ISO Technical Committee 212. And in prior years, I also sat on the board at AACC. No stocks, bonds, honoraria, expenses, royalty income, etc. But if you want to make me an offer, we can certainly discuss it. Our abstract for today, we're going to focus on molecular diagnostics, which has become a major issue in the last couple of years. What remains constant in a changing field with molecular diagnostics and other assays is the need to maintain rigorous quality management practices, including quality control, quality assurance, quality management systems, and we're going to review many of those. Also, as we mentioned at the bottom of the abstract, there are multiple regulatory and accreditation issues to be concerned, and we'll review what some of those are as well, especially as how they impact on considerations for implementing a quality system in laboratories. Our learning objectives today, as you may have read these before, we're hoping by the end of this webinar you will be able to describe the relevant regulatory and quality system management principles as they apply to your laboratories, to design quality control strategies for molecular PCR-based testing methodologies and for other methodologies as well. They don't change too much, and to identify tools for how to help implement those strategies. Our agenda will go part one, will focus mostly on the regulatory and quality management systems. Which ones applies, we'll look at a few quality management systems, particularly the ones from CLSI and from ISO 15189. And we'll also touch on accreditation requirements, such as from CAP, Joint Commission, and in many countries, accreditation requirements for ISO 15189. Part two will be more focused on control strategies, tools, and management, and we'll run through all these kinds of examples here as well. To start, let's understand a quality management system, or QMS as we'll often refer to it. It starts with research investigation and needs assessment. You got to know your own situation and what your needs are and what your customer needs are, your customers being the patients, the physicians, the other departments in the hospital perhaps. You have to establish a QC strategy, establish the troubleshooting practices, know what they are in advance. You know, select the quality control materials and the frequency with which they need to be run, and how are you going to track the results? You know, this needs to be decided in advance before you start actually running them. And then as you go through, you're going to reevaluate it periodically and implement updates and changes. And this is all inside the outer red arrows for reevaluation and improvement. This process does not end. It's a continuous process improvement effort, and just plan on doing this multiple times over the course of your careers. Why do we need a quality management system is the question. The answer is the cost of poor quality is more than the cost of quality management. Laboratory errors occur due to these types of factors that are bulleted here on the list: lack of training, attention to detail, time, sample control, quality control, workload management, etc. And this is not a complete list. There are others as well. And the cost of making sure these errors don't happen is less than the cost of dealing with the wrong results when they do happen. which also raises a question we should probably address. How do we define quality? What is quality for our purposes here today? And let's use the definition that says quality is providing the right result at the right time for the right sample from the right patient. And that's the definition we're going to work with. A short case study, this from is a major U.S. academic medical center, University of Oklahoma. They did a process flow chart, and this is what they came up with. These are all the little processes within their clinical laboratories. 113 steps, okay, is what they discovered they had. They didn't realize they had quite that much, and this is somewhat, there are a few missing here, but this is what they came up with. They approached it from the perspective, a very good perspective, that said every step, every process, every box is an opportunity for error. And the point of trying to reduce the number of boxes, improve the process workflow, is to reduce the opportunities for error. Out of the 113 steps, one, this little red box right there, says analyze. I know it's too small to read. It says analyze. The other 112 steps is leading everything up to the analysis and everything after the analysis. So it's pre-analytical and post-analytical. There's only one box that actually says analyze. So maybe we don't want to get too focused on what goes on inside that box. We certainly need to take good care of it. But I would caution not to get too focused on that, because we need to back up a little bit and see what else is going on here. The University of Oklahoma, by the time they finished, had their workflow down to 23 steps. And the advantage here is fewer steps is fewer opportunities for errors. Okay, they also eliminated, and you can see all the boxes that have been X'd out, and they've been marked. They could have been highlighted for a biological or infectious hazard to either patients or staff. They could have been possible wrong answer scenarios, and staff safety issues, repetitive motion injuries, things like that. They also, not necessarily shown on here, but you can go read the article, eliminated what are called wait states. The sample is waiting, is in the status of waiting for something else to happen before it can move on, and they eliminated as much of those as possible, and their turnaround time improved dramatically. Still only one box says analyze, but it's now one of 23, not one of over 100. A perspective to think of is we have to look at the whole lab to understand what's going on inside the analyze box. Coming up, we're going to talk about quality management systems, guidances, CLSI crosswalks, and then risk management and Iqcp. This is a CLSI document, and it's the leading CLSI document on quality management for laboratories. It's an important document. It's the parent of the other CLSI documents. And one of the things it goes through, well, several of the things it goes through, it's applicable to these disciplines up here are covered within the document. It describes the laboratory path of workflow from pre-examination to post-examination, or in different terminologies, pre-analytical, analytical, and post-analytical. Even out of all the steps here, there's also just one that says examination performance. That's the equivalent of analysis on the other flow chart. Lots of things go on before and after that. The quality system essentials, there are 12 of here. These are the essential elements of any and every quality system. And we'll look at a couple more of those briefly. Recognizing here in the purple bar at the bottom, this is all still under international and national regulatory and accreditation requirements that these need to follow. So CLSI does publish a series of QMS documents, and most of these deal with individual quality system essentials, the 12 little boxes we saw on the prior slide. So those are addressed, and we're drilling down into each one of those areas. So the bottom line is to follow through the regulatory and accreditation requirements, and which are most likely to make sure you address every one of these areas. The fundamental principle is these are the kinds of documents that describe how you do that. And we distinguish that from other requirements that come from places like ISO, FDA, CAP, Joint Commission, regulatory and accreditation places. They designate the high-level requirement, but often do so without giving guidance on the details of how to do it. These organizations tend to define what to do. So labs get accredited to these standards, often without detailed guidance on how to meet those requirements. CLSI documents are much more focused on the implementation process, how to do it. So CLSI worked closely with these other organizations and others in developing the CLSI documents and the crosswalks to make sure they accurately portray the how to do it part of what the other organizations are telling you what to do. We're going to show a few CLSI accreditation crosswalks. There are 4 of them, one each for ISO, CAP, FDA, and Joint Commission. These are the 4 documents. Again, FDA, Joint Commission, ISO, and CAP accreditation. Here's the website for where you can get copies of these, and they're free. You can just go to the site and download them. What they provide is, here's the one for FDA. It's a list of the CLSA documents that FDA has said they will, if you follow these documents, they will accept the results that you come up with from that protocol. Various testing protocols. Here's a whole section on molecular methods, method evaluation, laboratory quality systems management. This goes on for quite a number of pages. I forget how many, but it's like 20 or 30. Similar separate document for ISO. And here we have 3 columns actually for ISO 15189, the dominant clinical laboratory accreditation standard around the world, mostly outside the US. ISO 17025 is for testing and calibration laboratories, of which IVDs are a subset. And ISO 9001, because many of these documents are used in 9001 certified organizations as well. And we have, these are the CLSI documents row by row that satisfy this page of requirements. And the requirements go on for many pages. This is just an example that includes things like risk management. It starts with EP23, and we'll talk about that more in a moment. Laboratory quality assessment and how to manage risk management. I'm sorry, not quality assessment. Risk management and how to perform a risk management analysis. We look at CAP. The columns here are various elements of these columns up here, various elements of a CAP accreditation checklist. And as you go down the rows, which CLSI documents satisfy a particular requirement in the checklist. Many labs find these extremely useful in their CAP accreditations. And finally, we have Joint Commission, another major laboratory accreditation body, similar sort of setup. The columns are what the accreditation checklist says. The rows are which CLSI document satisfies which accreditation checklist items. It sounds like a lot of stuff, but CLSI has worked very closely with all of these organizations and some others to make sure everybody's in agreement on how all this works together. You have a choice when an inspector comes in to accredit your laboratory, you have a choice of 2 different types of conversations you can have. Conversation number 1, the inspector asks something like, how did you test to determine the performance characteristics of that assay? And you could answer, well, I followed the procedure according to CLSI document number, whatever the number is. The inspector will most likely say, very good, please show me the results of that testing, or maybe very good, let's move on to the next topic. All nice and clean, all taken care of. Conversation number 2 is a little bit different. The inspector still starts by asking, how did you test to determine the performance characteristics of that assay? And you say, well, we developed our own in-house testing procedure. Well, that just opened up a can of worms, because the inspector is going to respond with, please show me how you developed that in-house testing procedure. How did you validate it? What did you do? What did you calculate as the statistical power of your procedure? How did you do that? Et cetera, et cetera, et cetera. Questions after questions. You have to prove that you did a proper testing procedure, how it was validated, how you knew, how it was tested, et cetera, et cetera. So the question you need to answer is there at the bottom of the screen. It says, which conversation do you want to have with your accreditation inspector? Conversation number 1 or conversation number 2? Your decision. People want to have conversation number 1. Follow the CLSI protocol. The inspector says, thank you very much. Most times, most places, that's pretty much how they work. I want to go into CLSI EP19 here for a moment. EP19 is a framework for using CLSI documents to evaluate measurement procedures. This is a report. Technically, it's a report. Uses the measurement procedure life cycle as a framework to aid users in understanding evaluation protocols, particularly CLSI protocols, during established implementation. Measurement procedures developed by both commercial manufacturers and clinical laboratories, including for laboratory-developed tests, LDTs. There's been a lot of discussion, at least in the U.S., about laboratory-developed tests and how they need to be evaluated, established, verified, validated, implemented, who can use them, who cannot use them. A lot of that will be described in here with the focus on the measurement procedures. This website, the link is shown here on the left, where you can go in to get this document, and it's free. CLSI provides this to anybody who wishes to download it. A moment about some LDT considerations, lab-developed tests, and I don't want to spend a lot of time on LDTs, and we'll move on from here in just a moment. To be classified as an LDT, it's a single laboratory developed and used, authorized physician instruction, CLIA certification and accreditation, to be used only by that laboratory and will not be marketed outside of that laboratory or that facility that the laboratory is in. So the FDA is proposing much more rigorous regulatory frameworks for lab-developed tests, especially as tests have become more complex, and a large number of tests that were developed for SARS-CoV-2 as well, and how in-house methods, lab-developed tests, and they're getting a little concerned on how those are being handled and measured. The laboratory tests are classified as high complexity by CLIA. So the requirements include demonstration of the analytical validity of the test, quality assurance protocols, and presence of qualified personnel. All of the elements that we saw earlier in the CLSI quality management systems document, the quality system essentials, the QSEs, a dozen of them. They're all, FDA will want to see all of those elements satisfied. So the EP19 document on a framework of methodology, it has some background. There's introduction to the measurement process lifecycle, establishment of the design and validation, and then the implementation of how you actually put that test into use. There are various special cases here at the bottom that they go into. One that many labs need reminding of is, here's line 2.5, establishing acceptance criteria. Much like we have to do in other quality situations, establish your acceptance criteria. What's considered acceptable performance? How good does the precision need to be? How small does the bias need to be? How linear does the assay need to demonstrate, et cetera, et cetera. Establishing acceptance criteria, because it's entirely too easy to get to the end, looking at the data and say, oh, that's probably good enough. No, you really do need to establish those acceptance criteria up front before you start running the actual performance tests, and understand what is good enough. You know, you talk to your physicians, you consult with patients and nursing staff, and what is the clinical need that needs to be satisfied, and then establish your acceptance criteria up front and in advance. Within the same document, one of the points EP19 makes is the most relevant CLSI document on QC is CLSI document C24, Statistical Quality Control for Quantitative Measurement Procedures to monitor for bias and precision of measurement procedure performance over time, etc. That's the statistical handling of the quality control. And again, I'm not going to spend a lot of time on that today. Lots of material written on statistical quality control. In addition, laboratories may base QC testing frequency on risk assessment, as described in CLSI document EP23, Laboratory Quality Control based on risk management. Okay, let's do that. CLSI EP23, Laboratory Quality Control based on risk management. This is the table of contents, and we can look at some of the sections of what does it cover, and we're going to spend a little time with these. The introduction, terminology, etc. Chapter 2, path of workflow. Chapter 3, quality systems essentials. Okay, here's a little mini test. Where did we hear that terminology before? Well, when we looked at the CLSI QMS 1 document that laid out the parent, that was the parent document to lay out quality management systems. There was a whole section on path of workflow. There was a whole section on the 12 quality system essentials. This document on how we do risk management is based on those same model that's being used there. Path of workflow. Have a process flow chart. Hopefully not as complex as the one we saw from the University of Oklahoma earlier. Not as complex as the one the University of Oklahoma started with. They ended up much better than that. But understand the workflow. Again, much like we saw before, start with information gathering for risk assessment, go on to process mapping, etc. And just the same sort of process that we went on before. The quality system essentials, you see most of these same elements repeated from the documents we saw earlier. Let me offer a perspective on risk management. So all of us make risk assessment and risk management decisions every day, often without realizing it. Even the question of, should I go to work today? A bit of a fable about risk assessment. So should I go to work today? Well, driving to work is dangerous. There always seem to be traffic accidents. I may be better off staying home. But I can't work remotely, and if I stay home too often, I'll lose my job and I need the income. I better go to work. But if I go to work, I can catch diseases, even just colds and flus, other things, from people at work. I'm going to stay home. But we realize more people die at home than anywhere else. Home can be a very dangerous place to spend all your time. So I don't want to stay in this dangerous place, home. I'll go to work. And you can, and this conversation with yourself can go on and on and on. And you end up being very indecisive on what's the right thing to do. We need to recognize we manage this kind of risk every day. We make the decision every morning about, should I go to work today? There are pros and cons. There are risks and rewards. We need to understand, sometimes we need to understand what we do without even knowing that we do it. So let's not obsess over all of the risks that are possibly out there. Yes, they're there. But one of the things we also balance is not only risk versus reward, but also what is the probability of that risk happening and what is the severity when it does happen. So yes, it's useful to do risk assessment, and it may be required, and actually it is required in some, but no, don't get obsessed by it. Develop a prevention plan and a mitigation plan. So it's an issue of are there things we can do to prevent that risk from happening? If it does happen, are there things we can put in place in advance that will mitigate its impact, lessen its impact? So we can, things that can prevent it from happening, or things that can deal with it effectively if it does happen. That's how we're going to go through risk management. Quality control is an important part of those plans, but it's not the entirety of those plans. The other thing we're going to mention a few times is Iqcp, the Individualized Quality Control Plan. This is a very useful tool. It's outlined in the CLSI EP23 document that began this section. In many places, it is a regulatory and or accreditation requirement. And it's a good exercise to evaluate your laboratory and your assay capability in terms of these 6 bullets here. What's going on with the specimens? How well are the personnel trained? How do you know that they've been trained well? Do you test them periodically? How well are you storing the reagents? How do you assure that they're in date? What is the environment in the lab? Is there a maximum and minimum temperature, and how do you monitor that? How do you know it's actually being kept there? The same questions about the test system, same questions about test result. From this assessment, you can then go on to develop a quality control strategy and plan. But these have to be answered, for the most part, not generically, because you need to funnel this down into what's going on in your lab, but from your analysis of your laboratory needs and your laboratory processes and how things work there. A little guidance as we think about risk management and Iqcp. One of my favorite lines came from Eleanor Roosevelt. Learn from the mistakes of others. You won't live long enough to make them all yourself. True. There's a lot to be learned from other people's mistakes. And you go talk to them. Many people will be open about, well, we did this and it didn't work well. You can assess, is that only them, or would your story have been different? Probably not. Your story would probably be similar, so things to look for. A few more quotes and principles to keep in mind. These are from me, but I borrowed them from other people. Learn from other people's experiences, very similar to what Eleanor said. Use published templates. You don't have to write up your own Iqcp template or quality assessment template. Many of them are out there and have been published already. Your situation, your laboratory, your process may have unique elements that are not seen anywhere else, but not every element will be unique. You're not that special. Okay, recognize that how you do things is going to be similar to how other laboratories do things as well. Maybe not every element, maybe not all the time, but someone out there is probably doing something similar to the way you are. Invest a little time and effort, find them and talk to them, see what goes on. Because the last one, you don't want to reinvent any wheels. Okay, that's just waste of time and effort if somebody's already resolved it. You can work with them and learn from them. And to help you do all that, there is the CLSI EP23, which we just reviewed, ISO 1589, which we'll spend a little more time on in a moment, and other resources. Talk to other labs, talk to other people. How have they addressed some of these? Speaking of other resources, let's go to this gift that was just given to laboratories doing molecular tests. This is the April 2022 edition of CAP Today. Many of you may get this monthly magazine already. In April 22, it's only 2 months ago, 2.5 months ago. And we're on the front page, you see in red, on the lower right corner there, first IQC template set up for molecular tests. Okay, it's a fascinating article, and I consider this a gift to laboratories who do an IQCP for molecular testing, because it runs through how do you do it, and they provide the template for doing it. So this is from the article, and key points. This is a joint effort between the CAP, the American Society of Microbiology, and CLSI, the Clinical and Laboratory Standards Institute, working together, developed this first IQCP template that has been set up for molecular tests. Now, this is the first page, or first 3/4 of a page, of a rather lengthy CAP article, CAP Today, the magazine. tends to publish very long articles. So this goes on for a number of rather large-sized pages, but there's a lot of information in there. Note the link down in here in the yellow at the bottom of the slide. That is a link to other online documents, including the Iqcp template, which is this one here. Iqcp template for QC, links for how to get there. It's 11 pages long. This is like the first half page. But you can go through that, and it just walks you through the whole process for how to do an Iqcp for quality control of a molecular test system, XYZ, whatever test system you're working on. And then finally, again, back to the CAP Today online article, and that's the link to the article. They address questions like, what's the minimum frequency of QC testing that needs to be done? Some accrediting agencies do have a minimum. Do you know what they are, and are you following that? Laboratories also need to meet the minimum that the manufacturer requires, that they set out in their instructions for use, their IFUs. What is your risk level? How much risk are you willing to tolerate? And what role would external quality control testing play in that? And it's not necessarily the same answer for everybody, but they're probably not going to be too different from laboratory to laboratory. So that's all I wanted to spend on risk management, but we're going to come back to it shortly. Let's move to the ISO 15189, the international standard, and the title, the specific title of this document is near the bottom here, Medical Laboratories Requirements for Quality and Competence. Now, this was the third edition, published in 2012. It's getting a little dated. There is a new version in the works, an updated version, which should be completed and released by the end of this year. So this document will be 10 years old by that time. The document will be making revisions and updates, and into today's world, we don't anticipate it changing dramatically, but keep your eyes open for when the new version is published and take a look at it as well. Now, in the US, 15189 is not as commonly followed. Most laboratories are not accredited to it, but some are, and an increasing number are. In rest of world, Europe, Africa, Asia, South America, this is the dominant, by a large margin, the dominant laboratory standard, the dominant accreditation standard. Most laboratories in the world outside the United States are accredited to this standard. So be aware of it. The bad news is it's not free. The other documents we looked at before are free. This one is not. So don't be surprised. Let me start here with risk management, 15189, section 4.14.6. Talks about risk management and how to go about it. Down here in this section, it talks about section 4.14.7, quality indicators, their terminology, ISO terminology, pre-examination, examination, and post-examination processes. This is what many other places they would call pre-analytical, analytical, and post-analytical. Examination is the terminology that ISO uses. Be aware also of other terminology that ISO uses, especially if you're accredited to ISO. When an ISO document says shall, that's a requirement. It's non-negotiable. You will do any sentence that says shall. If you don't do this, you won't pass your accreditation, whatever the sentence is, if it contains the word shall. Alternatively, there are places where it will say should, and those are optional. They're suggestions. They're not required, but they're usually the smart thing to do. So I just want to distinguish shall and should because ISO has very specific definitions of those, and you need to work with those. A little bit on quality control. There's a lot in here. We'll focus on a couple. Here, section 5622. The laboratory shall, non-optional, you will do this, use quality control materials that react to the examining system in a manner as close as possible to patient samples. Important point. And it's also implied in the prior slide where I was talking about the entire examination system, the pre-examination, examination, and the post-examination. As much of that needs to be covered as possible with a given quality control material. The next sentence, quality control material shall be examined with a frequency based on the stability of the procedure and the risk of harm to the patient. So what did that just say? That is the risk assessment tool, the risk management tool that we discussed earlier. It's what is the probability or the likelihood of something occurring, that's the stability of the procedure, times what is the risk of harm to the patient or to a staff person from an erroneous result. That's the severity. It's all about probability times severity is your risk assessment. Another instance of the should I go to work discussion. What's the likelihood of something happening? How serious is that when it does happen? So what did that sentence also say? An alternate way of looking at the same question is how many wrong patient results do you want to have to recall? Because it does state that all results, if there are a lot of samples in between the first QC and then the subsequent QC at the end of the run or at the end of the shift or the day says something's wrong, how many samples were reported out in that time period? Because all of those results need to be either rerun and or recalled. How many do you want to have to deal with? Most labs, it's not many. So that's an argument that says run QC often. The usually recommended plan here is that start any new procedure with very frequent QC. Run the QC often. Then evaluate the frequency of errors, evaluate the frequency of instrument issues, how often something goes off, evaluate how wrong those test results can be or have been, and then you can adjust the QC frequency based on the error rate that you observe and on the potential severity of the wrong answers that the instrument might have generated or might not have generated. Maybe you can extend the QC significantly, but at least you're doing it based on data, not based on a best guess. So most labs don't want to have to rerun or recall a lot of tests, so that's how you can approach that, especially with a new assay. QC levels. The laboratory should, so you don't have to, it's just a really good idea, choose concentrations of materials at or near clinical decision levels. So start off your analysis with what are the clinical decision levels for this test? Maybe it's a qualitative, quantitative test. That's fairly straightforward. Then maybe it's not. Figure what are the limits in there. Again, independent third-party controls should be considered. Do you have to? No. It's a really good idea when it says should. Independent third-party control help, and they say either instead of or in addition to any control material supplied by the reagent or instrument manufacturer. There's a lot to be said in favor of third-party controls. Data management. Let's talk about data management for a couple of minutes. The laboratory shall, non-optional, have a procedure to prevent the release of patient results in the event of quality control failure. When the quality rules are violated, the results shall be rejected and the samples re-examined. Shall be rejected. We have shall again. Near the bottom, data shall be reviewed at regular intervals and preventive actions shall be taken. Every verb on this page is shall. I don't think there are any shoulds in here anyway. These are very direct instructions for how to do data management, and there's not a lot of optional ways of doing this, at least on the 15189 international standard. So as far as data management goes, we have molecular methods, molecular labs have historically relied on some combination of manual methods, spreadsheets, various non-integrated software to meet data management. And historically, that might have been fine. It's really not in today's world. There are increasing testing demands that need to manage and review data. They need to communicate with the hospital system and patient reports and nursing stations. Labs must consider, kind of halfway between shall and should, must consider upgrading to a laboratory information system. The thing to keep in mind perhaps about that upgrading to the laboratory system is, remember the two conversations with your accreditation inspector. Conversation one was you followed a protocol, or in this case, maybe you purchased a commercial, from a commercial company, a laboratory information management system. When the inspector says, so how do you know your your information system is working? Well, the manufacturer runs this sort of validation and it's et cetera. If it's, you can write your own software, but now you're in conversation number two. How do you know it works? How do you know, how did you test it, et cetera? So decide which way you want to go on that. Interlab comparisons. This is back to, you think a little more broadly than just inside the analyzed box, more broadly across the lab. And the laboratory shall, non-optional, participate in an interlaboratory comparison program. External quality assessment, as it's called some places, proficiency testing program, as it's called other places. There are a lot of other sections of 15189 that describe the larger, broader laboratory quality management system, quality process, and we need to be aware of what those are. So best practices in QC strategy, think of QC broadly as one element of total risk assessment. What are the minimum QC needs for the manufacturer's instructions for use? That needs to be a factor in your assessment of what needs to be done. It's usually considered a minimum. There are ways through that. Perform a risk assessment, please, and an Iqcp, an individualized quality control plan. What do they show that needs to be controlled? They may show that some things don't need to be controlled. And how do you go about doing that? Understand the total laboratory picture, the total laboratory processes, and where the risks are. Very importantly, perhaps most importantly, as we say here, test the entire testing process from pre-analytical handling and sample prep through analysis and result reporting. Don't assume everything outside the box is taken care of. It may not be. So if you're going to run QC, look for things that are whole organism QC. So extracting and test result reporting from the system. And if you're going to deal with a whole organism QC, it's usually recommended to make it inactivated. We don't need to bring biological hazards in. Best practices in materials, as many of these are recommended by the 15189 standard, as well as just general good idea. Independent of manufacturer, third party, independent of the analyzer, internal controls, can be used on multiple platforms independent of platform. This, by the way, is also a mechanism about inventory management. You know, if you have one control that works on several platforms, that's a lot easier to manage and can often get you volume discounts to improve the cost issues. Useful combinations of organisms, ease of use, safety, all sorts of good things here. This is where we started with this wheel of reevaluation and improvement. On the left, these are all the other people who get involved in your laboratory. You need to know a lot of regulatory and accreditation issues. You need a lot of regulatory expertise and accreditation expertise to help get through all these things. There are a lot of people trying to manage laboratories. Educate yourself, become an expert, or consult with regulatory and accreditation experts. Most of them are well worth their money. They could come from other labs. They could be consultants. You could grow your own ones at home. The rigorous program will increase your confidence and enhance efficiency. It's just the right way to go about it. Make sure this is done right. So in summary, we covered regulatory and accreditation requirements. QC is one element of a larger quality assurance, quality management system program. There are resources and guidelines, CLSI, ISO, the crosswalks, the templates that are provided. Distinguish who's telling you what to do versus who's telling you how to do it and providing that guidance. We discussed risk management in Iqcp, best practice QC strategies, best practice QC materials. So with that, I want to thank you for your time and attention. We hope we answered a lot of your questions that you came in with. And at this point, I'm going to turn it over to Jessica Van Allen to go into some specific applications of quality control solutions. So Jessica.
Great, thank you so much. So I'm Jessica Van Allen. I work for Zeptometrics. I'm the lead technical support there. And I'm just going to take a few minutes here to speak to how I think Zeptometrics offers a quality control solution for your laboratory. So like Dr. Zakowski touched on in his presentation, quality control is one small part of a laboratory's quality management system, but one very crucial part. And clearly one way to ensure accuracy in diagnostics and improve patient care is through the use of external quality controls. You know, this is not a new idea. Like the presentation covered, many accreditation and regulatory bodies explicitly recommend the use of third-party external quality controls in the laboratory. And Zeptometrics offers a unique solution in these areas with our natural inactivated molecular products. So these are just a few of the attributes of our molecular products. So as you can see, there are a number of attributes that make Zeptometrics controls an optimal choice for molecular testing that actually directly correspond to the ISO 15189 standard that was just talked about. And really, I think what it comes down to is to determine exactly what is most important and most relevant to your laboratory specifically when thinking about quality controls. You know, what are some of the most important considerations for your laboratory environment, your staff, for the tests that you are running? Is it most important to you that the material is inactivated and non-infectious and thus safe to use on a benchtop? Or is it important to you that the material contains the whole intact organism and works as a full process control for your test? Or is it most important to you that the material is ready to go, easy to use, you pull it out of the fridge and it's ready to work with? Or do you have minimal freezer space in your laboratory and you want something that can fit into a refrigerator? All of these things are reasons that labs might come up with to avoid doing quality control testing. But I think we approach many of those issues with a solution with natural inactivated materials. So they're non-infectious, and the inactivation of our organisms is verified in validated growth protocols for each organism. And they work as a full process control, like I just mentioned. So they contain the entire microorganism. So it's not just a portion of the genome. It's not just synthetic sequences of RNA and DNA. So what you get is a sample that mimics a true clinical specimen and allows you to control for all of the processes involved from the extraction, amplification, to the detection of the organism. Conveniently, natural controls are also refrigerator stable, meaning they're ready to use in a liquid format. That allows you to have multiple reuse capabilities on these materials, so you don't have to worry about if you're using, say, a synthetic RNA DNA, degradation that might occur during freeze thaws. You can just keep your natural controls in the fridge and reuse as needed. This obviously is also a cost savings because they're not shipping on dry ice, they're shipping on gel packs. And other things natural products contain a 1 to 2 year stability. So it's a really nice shelf life that works well for, say, you're using it to compare different lots of reagents for an assay. So you can keep one lot of Zeptometrics controls, and that way you can test as you get in, 2-3 lots of reagents for your assay over the course of a year. They're traceable to WHO international standards if they are available. And really, they're developer preferred. I think Zeptometrics has a really unique position in the industry. We work very closely with a lot of assay developers and also with our customers to find solutions for labs that work across different platforms and different assays. So like I just mentioned, I think we're in a really unique position between diagnostic test developers and end users in the labs who are running the tests. So with that, we have a really unique perspective and insight into the market and have really grown into our ability to troubleshoot and offer insight to our partners and customers really across the infectious disease diagnostic field. With this unique perspective, I think comes a responsibility and really an opportunity to work closely with laboratorians and clinicians every day to find solutions within their own laboratories using the resources at hand. I think that's another advantage for purchasing external quality controls through a third-party vendor like Zeptometrics, and that the quality is guaranteed. You know, we maintain good manufacturing practices as our manufacturing facility is ISO 13485 certified. So when you buy a third-party control from an external vendor, you're backed by their quality management system. And that also comes with support from customer service and from technical support if an issue ever arises, or if you have any questions, or you find yourself having to troubleshoot something down the line. You have that support system built in. This slide just touches on a few of the areas I think Zeptometrics can help labs, from everything from research and development. We have quantitative options, linearity panels, a really broad organism offering, and then things like routine QC, day-to-day QC with external run controls, and then bringing on new platforms or tests into the laboratory with things like verification panels and some quantitative controls. So I won't keep you much longer, but I think many of the quality control solutions I just touched on can really help labs in establishing their quality control plans. You know, these solutions can really apply across labs who run both IVD and LDT tests. Not only do we have agnostic controls that will work across multiple platforms, thus saving you time and money, like was talked about during the presentation, but we also do receive feedback from customers using our products in the field. So we get information on what commonly used tests that our materials actually perform really well on. So that, coupled with in-house testing we're able to perform, gives us a really great insight into the performance of a majority of our control materials on various platforms and assays on the markets. And I think all of this really is just to say that we at Zeptometrics are really happy to work with our customers to try and find a quality control solution that is right for your laboratory. Like we just discussed through the talk, you know, it can be a complicated thing to do. So we're really ready, willing, and able to help you at least attack the quality control solution part of your problem. And with that, I think we will take questions.
Yes, thank you, Jessica. As a reminder to webinar participants, if you have a question, please type it into the Q&A box in the control panel. We'd also like to ask attendees to take a moment after the webinar has ended to take our exit survey to give us your feedback. And we'll now start the Q&A portion of the webinar. And the first question is, I think for you, Jack. With so many conflicting guidelines, how do you know what supersedes what?
Great question. It is a very complex field. And I touched on that a few minutes ago when I said have to develop local expertise. Part of the somewhat facetious answer to that is it depends on where you're located. What country are you in? What state are you in? They do vary from country to country. What is the dominant regulatory organization in your country? What do they specify? Who are you accredited to, or who you're accredited by? What organizations? What do they say you need to do? For the most part, the different then there are also national standard bodies that help to administer things like an ISO 15189 and other ISO standards. It does get very complex. You need to know what your local regulations are. The different organizations that regulate laboratories usually don't disagree too much, but they do in some places, and then it becomes a challenge to know which one do you actually use. Mm-hmm. Again, I'm going to go back to the recommendation I made earlier. You need to either develop a lot of in-house expertise on the regulatory and accreditation requirements to really understand what's going on in your geography, in your country, in your state, or bring in someone who does. Okay, and have them sort out for you what is your local requirement there. So. Okay,
and doing a full assessment in Iqcp, it takes a lot of time and effort. Is it all really necessary?
Yes, it is. Okay, and it does take a lot of time and effort. It does take a lot of time and effort, but it is necessary. without doing an Iqcp or something that looks so much like an Iqcp that it's hard to tell apart from an Iqcp, you don't have a very good understanding, you likely don't have a very good understanding of where are all the potential sources of error in your laboratory and in your laboratory processes. How can you prevent those errors from happening? How can you mitigate them if they do happen? Without going through a disciplined, consistent, rigorous analysis of your situation, of your laboratory, of the environment, of what kind of training people are getting, how you monitor your environment, how you monitor the effectiveness of the training of the people. It's not just about run a QC on a platform and is it within 2 SDs. That's fairly straightforward and fairly trivial compared to a lot of the other questions you're going to be asked to answer on Iqcp. However, having said that, yes, they are difficult. They can take a lot of time and effort. There are a lot of tools out there to help you get through that. There are Iqcp templates, and we talked about the new one that just came out 2 months ago for use with molecular methods. Go to that one. Yeah, it's 11 pages long, but you can run through it, and it's, check this, check that, check this other thing. And it's not like it used to be years ago when there were not very many templates around. The last thing I might add on that topic is, yes, they are hard, but many of the ones you need to do, and many of these will be instrument or platform specific, but after you've done your first one, that's the hardest one. After that, they get easier because the systems are within your laboratory are probably very similar. So when you do the Iqcp on another platform, it's not going to be too terribly different. And also, you're more experienced in doing them as well. You probably don't have to do quite as much research to do the second or third or fourth as you did your first. So yes, it does take a lot of time and effort, but there's a lot of benefit to be had from it. So I would say yes, it's necessary.
Right. Okay. Thank you. And Jessica, if a lab uses positive patient samples for quality control material, is that okay? Is a third-party option needed?
That's a really great question. And, there's not a super straight answer in that. Is it okay? Sure, as long as, they're well-characterized patient samples. And, there's a thoroughly validated process there. Going back to, like Dr. Zakowski talked about, you want to consider that conversation with an inspector. You're going to open that can of worms if you're using these positive patient samples. A lot of times labs use them because they're, in quotation marks, free, and they're available. They're on hand. But I think in considering that, you have to really think about that. Those controls and making them yourselves, it really doesn't immediately represent the additional costs that go into preparing them and validating them and storing them with the labor and the time to create and document everything that goes into it. So can you use them? Of course you can. But again, you have to consider the costs to you in terms of time and effort and resources in order to use them. So like I talked about, if you buy a third-party external quality control, then I think you're more looking at that conversation number one with the inspector, where they're saying, oh, okay, great, you bought them from here, they're ISO accredited, there's a quality management system to back them up. So I think you'll find that you have much more support if you buy a third-party external quality control, and kind of the peace of mind and a lot less upfront work if you go that route.
Okay. And I think we have time for just one last question. So what is the best way to stay current when guidelines get updated?
I'll take that one. It's that can be a challenge. You have to kind of pull them or get on their mailing lists. Okay, ISO, CLSI, whatever. As a longtime CLSI member, I'm going to say become a CLSI member. Okay, it's a little self-serving, but I don't get royalties or anything from them. And you'll get all sorts of email notices. You can be an individual member, but recognize if your organization if your laboratory or your hospital is a member, then all of its employees are also members. So you may be a member and not even know it if your organization is a member of CLSI. So it's a great benefit to the organization to do that. Additionally, you also then become eligible to volunteer on document development committees and help write new documents, update old ones. And you also get to vote on draft documents and comment on them, and you see what's coming down the pipeline at you by looking at some of those as they get sent out for drafts and comments. So ISO also has a process where you can participate on a sort of an advisor type basis, looking at some of the documents that they're coming through with and see what's coming down the pipeline there at you as well. Those would be my recommendations.
Okay, thank you. And so that's all the time we have for today. We'd like to thank